Hello, welcome to Tech Talk with Steve, episode 50. Wow, 50 episodes, hard to believe. Today we're going to be talking about hybrid powered fiber cabling and test solutions. You've heard us talk about testing hybrid powered fiber cables before. Today we're going to have a special guest on, and it's always exciting for me whenever we have a guest on because it's not just my mug on the screen and my voice droning on. I actually get to learn something. Which actually I learn something every time we do one of these based on questions we get from people. So it's always good. So today we have with us David Stenger, who is the Global Product Line Manager for Powered Fiber Solutions at Commscope. For the last 25 years, David has been at the forefront of powered fiber innovation, working with Ethernet and the succession of PoE standards. He is also responsible for Commscope's emerging Class 4 fault managed power for enterprise networks. Welcome, David.
Thank you, Steve. Really appreciate the opportunity to be here. I really love your content. It's been both as informative as it is practical.
Thanks. Appreciate that. So to kind of lay the groundwork for everybody today, I'm gonna basically hand this over to David. He's gonna talk to us about some of these emerging technologies and talk about the drivers behind this type of technology. Why are we seeing more demand for it, and where we're headed in the future? So I'll just hand it right over to you.
Sounds great. Okay, I'm going to go ahead and share my screen. I have a lot of images and pictures to make this a little bit more understandable and to understand what the drivers are. So again, David Stenger, Global PLM for Powered Fiber, specifically in the enterprise market for me, and there are other applications for this product, but within the enterprise scope, that is my responsibility. Okay, so we work a lot with our customers directly. We have what we call voice of the customer, and that's an opportunity for us to meet with customers, in particular in the field, bringing prototypes with us, bringing demonstration products with us. So three main things that our customers talk to us about that they're looking at and want solutions for: densification, deployment speed, and sustainability. So think of densification not just as putting devices close together, but also consider how much we've expanded the number of devices that are used per customer, per end user, within the network. Densification is something that in part is driven with higher speeds. As you increase the frequency of transmission, you are beginning to limit your distance, and I think we're familiar with that from cell phone technology all the way to Wi-Fi. Second category that we hear the biggest needs for is deployment speed of the network. So today, at least here in the North American market, we have extremely low unemployment, and we have a shortage of qualified people that can do installs and maintenance and management of our network. So a lot of our products are geared towards making deployment faster. And we'll talk about that in terms of the architectures with hybrid powered fiber, but it's also something that we're doing to address the shortage in qualified people here. Sustainability is the third aspect, and this is something that is more prevalent outside the U.S. Than inside the U.S., perhaps with the exception of California. But there's a lot of programs that are driving sustainability, reducing our carbon footprint, using less mineable materials and less dangerous materials as well. All right, let's see here. Okay, so hybrid fiber systems, what is it? We're talking about cabling that is designed with both the copper and electrical cabling within the same cabling unit. And often these are designed in different subunits. If you look at the diagram in the bottom center, you can see that's 8 conductors of electricity on the left, and then a 16 fiber subunit there. So it's a combination of both cable types, copper and fiber, within the same cable. So this allows us to do some unique applications that we haven't been able to do in the past, at least not without significant effort from an engineering perspective, putting products or putting a solution together on our own. It takes the strengths of copper and fiber, and it does create a unique solution. Think about this as something that we can use when there's no local power available for a device. That could be that you have an existing network, you need to move systems, you don't have power available. It's designed specifically to be optimized for the medium distance and remotely powered applications. Now that it incorporates fiber within the cable, it's future-proofed for higher speeds. So, I'm sorry, too fast. So what it isn't, we're talking about hybrid fiber systems. They're not limited to 100 meters. They're not limited to 100 watts of power. At the same time, they're not a true AC replacement. And AC systems, we've been using them for years, and they have applications in terms of like motors and other high-powered devices that these hybrid fiber-powered cables are not designed to work in. So it is also not power on the fiber itself. This is something that's been talked about for years in terms of can we actually get some power on the fiber? Well, there is a product that I've found in my years of dealing with this that does put power on the fiber. So it is possible. Now, is it practical? And this is really a question. You look at the specifications of this product here. It is designed and built by a company, RLH. Power consumption, so we're inputting 75 watts of power, and the output is essentially 1 watt at 10 meters. So again, possible, not practical at this point.
Not very efficient.
Not very efficient at all. So, right, it'd take you over 4,000 watts just to power a common Wi-Fi access point or camera in today's market. So some of the applications, a good way to look at this, we're looking at short, medium, long distances. So in short distances, copper is optimal, especially from a cost perspective, and that's a full system cost. And when there's no local AC, for whatever reason that is, PoE is the preeminent solution right now in the marketplace. In terms of remotely powered devices, I am sure it is the lion's share of the market. Now, medium distances between 100 and 2,000 meters, typically what we're doing with our cable installs is a mix of copper and fiber, star topology, bringing fiber to TRs and going up and distributing it through different floors. So it's just a good mix of the different types. But powered fiber allows you to do the medium distance and include the remote power. So longer distances, as we all know, fiber is the best for that. So these applications we're talking about, small cell densification, new Wi-Fi deployments, video surveillance, IoT is driving a lot of this increase in devices that we're using. We have everything from IP phones to touchscreen panels at retail establishments. You look up your own pricing. So a lot of devices are being added to our networks. What are the most common methods for powering these devices? PoE, again, short distance, and 100 watts or less power. NEC Class 2, while PoE is essentially a Class 2 technology, this is about using the full capabilities of the copper. A lot of times what we do is we're increasing the gauge of the wire so it's able to be more efficient in how much power is delivered at the far end. NEC Class 4 is new. This is ratified last year in the NEC. It's Article 726 and all of the sub-articles. And so in this situation, we're looking at Class 4 power can deliver 600 watts at a minimum typically, and up to 2 kilowatts, perhaps more. It's really based on how many pairs are conducting power. I'm not going to cover all the data in this, but PoE, the important thing here, you're really looking at the top 2 lines of the power available at the PD and the power delivered. So as we've moved in time from the early 2000s with 15 watt IP phones to 30 watts, the standards moved also, 60, 90 watts is the most current. So, but that's really the limit in terms of Class 2 circuits. Another thing that's important is you look how we're delivering the extra power. There's more power per pair, up to 960 milliamps with the newest standard. Something else also to know is when you're using PoE, it is a defined standard that allows for interoperability between vendors. And in order to establish the connections and what level of power, there are protocols that will negotiate for that. So some products for the class 2 networking when we're outside of the PoE environment. So there's cabling, hybrid powered fiber cabling, number of electrical conductors, and a number of fiber. And vendors have their own solutions, different counts, different quantities, different fiber types, both multi-mode and single mode are available in the market. And when we're talking hybrid fiber cable, you need some mean to convert the power, the class 2 power, into a usable power at the remote end, most commonly PoE power. So a powered fiber extender is receiving the cable, the hybrid fiber cable, and it's splitting it into the power section, the fiber section. An example in this case here, this is a Commscope extender, and it has the cable termination, cable management built into an outdoor enclosure. And also that's powered supplies, the PSE equipment at the central side. We utilize a product that essentially has groups of 8 class 2 circuits. So in the power supply, you could have a central side with one device powering 32 connections. So what does the full solution look like? You have the central side, the power supply, the cabling itself, and the load devices or the end devices, whatever they might be, cameras, Wi-Fi access points. And these distances it's not actually PoE that's on the cable. We're talking about the PoE capability at the remote end. With a 12 gauge cable, we can deliver 15 watts at 2.6 kilometers. Class 4, as I said, it's new. The biggest components of this is we're using higher voltage and lower amperage to make it safe and to deliver a lot more power than is capable in Class 2. This is something that's expected to fall under low voltage, so low voltage contractors, and that's really depending on the jurisdictions. We've seen a mix when we talk to our customers. And the Commscope product will have Class 4 certification. That's very important. Certification is something that drives how you can lay the cable. So our product, Constellation, this is one of the opportunities that we've seen within the enterprise space is to deliver 5 times the distance with 10 times the power. And as you can see in the bottom left, we're producing significant savings in terms of materials, especially mined materials. So plastic and copper is reduced. This is a 2,500 cable project or 2,500 end stations. So that you can see the difference between doing a home run connection in Cat 6A versus using a distributed approach. And by distributed, I mean we're building cells with this product. We're bringing power to a location and spreading out from there. So depending on power requirements and data requirements, that'll determine how many cells you would deploy in your network. The equipment itself, we have the equipment room, the cabling, and in the service area, this is how we're distributing the power received over the Class 4 circuit. One of the great advantage of Class 4 circuits is you can power multiple devices with that as opposed to Class 2. Traditional patch cords and other equipment at the remote end is also can be used because it is a PoE output on the extender's electrical port. So how would you build a Class 4 architecture? Very similar to Class 2. You have a central side providing power. And in our application for the enterprise market, we have an enclosure here that is designed to be ceiling mount, 5 rack units of available space, AC power, DC power in both 24 volts and 48 volts. So the way that, as I mentioned before, the circuits are built out in pairs. So as you add pairs that are carrying power, you increase the available power. So it's also an equation of distance and power input. And as you can see, as you add pairs, you're able to deliver 1 kilowatt of power at further distances, starting at 150 to 500. Okay, so real quick with Constellation, multiple power levels that are available. So we do have people that are using HVAC controls and other devices, and those are often driven by AC-DC converters. We have native DC, Doesn't matter what type of technology you're using with hybrid fiber. Active Ethernet is the most common in the enterprise, but also we see PON networks being used with remote power. Saves in the materials and the labor. It's faster to install, doesn't need certification and as much planning. The device itself, this enclosure is secure from users. And if you want to talk in terms of like what we expect in the short term, we expect a product like this, Class 4 power, to be supplemental to a network at the beginning. Perhaps in 5 years or 10 years, it'll become a standard means to develop a network from a new install. So as a summary, we talked about hybrid fiber powered cables and the different applications. We've talked about the different means of doing it, PoE being the most common today. And PoE is a Class 2 technology, but it's very specified in terms of the electrical characteristics, just to make it more interoperable. And the Class 2 circuits, that would be using typically a larger conductor cable for 12 or 16 gauge compared to the 23, 24 in the newest twisted pair cabling systems. And the Class 4 circuits being new, it gives us the opportunity to drive enough power out to, say, a pole or to a location to power 4 cameras, or to power multiple devices from a single hybrid fiber powered cable. So in some ways, I think about this, will we see new installs of copper cabling that aren't using power in the future? I think a lot of times we can see that having a centralized DC power infrastructure with a hybrid fiber power cable is a great opportunity. So that's the end. I'll stop sharing my screen.
Great. Yeah, good information there. So, a couple things that stand out for me. I mean, obviously, most everybody's familiar with PoE now, and the initial applications that we've seen for the hybrid powered fiber have been extending PoE, where you're providing that Class 2 voltage across the pair of copper conductors out to a PoE extender, for instance, or a remote camera or device, as you mentioned, or access point even. But now it looks like Constellation is taking us beyond that, where you're actually implementing fault managed power, and instead of just using a single pair with 2 fibers, you're matching up every 2 fibers with another pair of copper, and with all those pairs of copper at the heavier gauge, you're able to provide that higher power level, DC voltage, DC current out at that remote end. So. And then all the conversion happens in the Constellation equipment, if I understand this correctly, where it brings everything back to a PoE for the devices that you're going to attach to it.
Sure. So the way that it works within Constellation is we're taking in a very high voltage signal. In our case, it's about 380 volts that supply, but much lower amperage. So, right, we're going to be able to extend that to distances 100 meters to 500 meters is really the sweet spot for this. So it does open up brand new applications at the same time, making installations faster and more sustainable.
Great. So one of the things that that people think about too, when we're talking about installing any kind of cabling, we want to test it, right? So we want to test the fiber, but what about the copper? That pair of copper you've got in that hybrid powered fiber, there's got to be a way to check it after you install it. Obviously, it's not going to be certified. There's no certification limits for electrical carrying conductors, 12 gauge, 16 gauge, 14, whatever you're using. But it's good to be able to check the integrity of it. And so what we've come up with, and I'm going to go ahead and I am going to share my screen here if I can find the right button. Yep, there we go. And so what I've got here is I've got a setup where I've got up above camera here off screen, there's a length of hybrid powered fiber. I've got 2 strands of single mode, and I've got 2 conductors. Not sure what the gauge is, probably a smaller gauge, stranded, maybe an 18. And then what I've got is I've got my fiber test adapters. My main unit's over here off screen, but you can see that displayed on the screen. And then here's my remote unit. So you can see the information on both ends. But what I've got connected that you may be able to see in the camera here, there's some wires coming out of the top of my fiber adapter. What that is, it's this little jumper. It's got a little electrical connector on this end, and then some alligator clips out on the other end of the jumper. And I've got one of those at each end. So what that does is it goes into our fiber test adapter here. So you've got your fiber test ports. We've got a light source port and a power meter port, and we've got that at both ends. So we're doing a bidirectional test. And then here's a little electrical connector that this jumper plugs into. And what we do with that is we connect those clips. Right now, you'll see on display, I've got a wire map here for fiber. If I disconnect one of my fibers, you'll see that wire map will drop out. And then when I connect, it will come back up. So we see the fibers connected. That's our live wire map, just like we have on copper. And then right now, my DC is not connected, but you can see a D plus and a D minus right here. So I'm going to take the leads coming from my main unit. I've already got the remote connected, and I'm going to connect to the electrical conductors on my hybrid powered fiber. And once I do that, we'll get a DC resistance measurement that's showing here on the screen. It's showing us a 1 ohm measurement. And I'm just going to go ahead and run an auto test. I've already done all my set reference earlier, so we wouldn't have to go through all that. And I've set my fiber limits and everything. But we're going to go ahead and run a test. And here we see our results. We see our margins at both wavelengths. We see the delay, the length of the fiber, and we see our resistance on this is 1 ohm. I can go in and view the individual losses per fiber, per wavelength. And then if I'd done a bidirectional test, there would be additional lines of test results here. And then at the end, we see the network limits. So what speeds we can run over the fiber, that's all based on how you set the test up. So it takes into account the length of the fiber, the loss that's measured on the fiber, the delay on the fiber, and the selection of the fiber that you've chosen. So in our cable library, you can choose a generic like I've done here, or you can select your fiber brand of choice. You can go in and choose your Commscope fiber that you're using for the application and select that, and then it will be set up properly. So based on the grade of that fiber, it will include that when it weighs all the test results against what you can run over it as far as speeds go. And you would save this test just like any other test result. And then, as you'd expect, when you've run your tests, you can go into the cable management software and you can generate your PDF reports. And here we see a test report of a fiber. I ran a fiber test earlier, and this one's got just under an ohm, 0.75 ohms. We see the length of the fiber. We see the loss values. All the pertinent information about the tester is here. And then, of course, the compliant network speeds that you're capable of running. So in this case, if you installed, like you were talking about, maybe it's, 8 strands of fiber or 16 strands of fiber and 8 pairs of copper that go with it. You could do, every 2 fibers and a pair of copper every time you're running a test. So you do your typical, 2 fiber test all throughout, and you would have that information about the DC resistance of that copper conductor. So when it's, when you've installed it, this is when it becomes critical, because a lot can happen during installation. That's why we certify fiber, so that we know that there aren't going to be any problems with the fiber after the installation, that it wasn't damaged, that it's been terminated properly. But also you want to check the integrity of those copper conductors. Copper's pretty beefy, but you can damage it during an installation. It could get nicked. If it had too much pulling tension, you can stretch the copper, which then changes the resistance. So a lot of things can go wrong. So it's always good to be able to verify that. And as far as I know, we're the only ones that have this type of test adapter with the certifier that you can do that. Otherwise, you would be reduced to just using a multimeter and checking it out, or you terminate it and hook everything up. And the old method that we used to use, you terminate and you plug everything in, and if it works, we're great. So,
right. One thing I'd like to add, Steve, in terms of outside of the PoE world, the Class 2 power and the Class 4 power that I mentioned, they require very stringent methods of installation, just because we're at the bleeding edge of what the power capability is. So testing is very important with these types of going beyond the typical limits with these systems.
Yep, exactly. So you've got, there are certain, and I'm not sure what types of tests are currently being done on the fault managed power, but that's that's certainly something we're looking into as well.
Mhm.
You know, beyond the the base fiber with the electrical conductors, you can test that. But once the fault managed power is in, it'd be nice to be able to run some kind of test. Now, my understanding is that the equipment probably has a lot of that diagnostic built into the
Mhm.
system. Is that correct?
That is correct. There's different means or different methodologies of how they provide the fault managed power between vendors, and we're using a technology from Volt Server, and we make that very public. But one of the advantages of using Volt Server and their digital electricity is they provide their fault managed power in terms of a packet of information that's exchanged between the transmitter and the receiver. And if there's any indication of a fault, then it'll stop supplying the power and restart after a period of time.
That's a huge safety issue too, because it's, a lot of people think about, oh, I don't know if you've ever heard the stories back when it was, Edison versus Tesla, the whole DC versus AC
Right.
thing. And
Hmm.
everybody was like, oh, you have to be scared of this. But the fault managed power takes away the threat essentially. So it's, my understanding is you could touch it and we've had Volt Server on, and one of the things I remember is you can touch it. You might feel something, but it stops instantly. But you don't feel pain. It's just like that something's there, but it's so
Yeah.
instantaneous that there's no chance that you're gonna sustain any damage to your cells or threat to your life.
Right, and it's considered safe enough to be used in installations without using conduit. So that's definitely an advantage to it as well. But safety
That's
is a key feature of this.
That's huge. I wonder though, thinking about this, how the unions get involved. There are certain parts around the country where I bet the pipe fitters union will still have it going in conduit. Um, I lived in the Chicago suburbs for a couple of years, and I was shocked when I went in the basement of the house and I saw conduit for all the Romex in the house, but that was
Hmm.
code. So,
Right.
it'd be interesting to see if they force that issue in some of the districts.
Sure, and that's why I brought it up. It's going to be on a jurisdiction by jurisdiction basis in terms
Right.
of is it a low voltage install? Is it electrician only? And those types of situations. I think we all remember when PoE lighting first came about, and there was depending on where you were, there was conflict between whether it was low voltage or the electricians were going to install it.
Exactly, exactly, and it's been that way for ages. Even when just the Ethernet cabling itself, when we first started having category cabling, that in some jurisdictions there was that fight about who's going to install it, and the heavy union areas pushed hard to have the electrical installers put it in, and there's some great electrical installers who understand datacom and can install it fine, but there were some back in those days that treated it like Romex. And I literally had somebody failing cable tests, and I asked them to explain how they terminated. Yeah, I maintained my pair twist up to within a half an inch, but yeah, I said, okay. I said, walk me through it. And they walked me through it and said, well, I had 2 feet left over. So I folded it up and pushed it in the box nice and neat behind the faceplate. I go, time out. I said, it's not
Right.
Romex. You can't fold it up like that in the box. They re-terminated, they cut off the excess and re-terminated, and they were fine. So it's
Right.
it's it's a learning curve for some of them.
Yeah,
Um,
and there's when you mentioned the means of which the fault management is dealt with. Today, the Class 4 is a designation of the specifications of the cabling system and how it would work as a full functioning system, including the electronics. So, one thing that it hasn't been done yet is the means of which you're providing Class 4 power. It's not standardized, so it is on a vendor by vendor basis, and you do need to have the same vendor's equipment today, at least on both the central side and the remote.
gotcha. So it's not an interoperability situation like you would have with different components for regular structured cabling, for Ethernet, for instance, where you could mix and
Exactly.
match. You can mix and match vendors. While not recommended, in my opinion, because if they're not tested as a system together, they're not always going to perform the best. But
Absolutely.
in this case, it seems like unless things change down the road, you have to make sure you've got that same vendor at both ends of that link.
Right, and there's some logic behind why it hasn't happened yet, in terms of we are pushing beyond the other standards that we use for power, and when you're at the bleeding edge of what amount of power you can provide, there's different ways to do it.
Yeah, so you've got each vendor's going to have a different proprietary way of transmitting and receiving and converting at both ends. So yeah, that makes sense. That makes absolute sense. So I didn't see that we had any questions here today. We had a bunch of people saying hi. I see my friend Patrick Shala from over in Kosovo is on today. He said hello a little earlier. I've talked to Patrick a few times this week. So good guy over there in Kosovo. If you need some low voltage cabling over there, go check him out. But we appreciate everybody joining us today, especially you, David. This has been very fascinating. I've been following the fault managed power thing for a while now, and to me, it's the exciting next thing for intelligent buildings. I think we're going to start seeing this become more the norm in the next couple of years, rather than an exception and an odd, ooh, let's go look at this building here or this building there. I think it's going to become the predominant architecture.
Yeah, it has the opportunity to provide everything that we need in the new networks, especially when we're looking at wireless first for typical data, and then we're having applications, especially in data centers, where speed's the primary need.
Yep, exactly. Well, again, thank you for your time. Really appreciate you coming on. This has been fascinating, and we are right there at the bottom of the hour, so we're going to go ahead and close out for today. We will have a special episode coming up in 2 weeks, episode 51. We've got an announcement on some new testing capability coming up, so you want to make sure you tune in for that. It should be very, very interesting. One quick question before we close out. Mohammed Jalbosh said, how would be the hybrid connector? So what kind of connector would you use on each end?
So within the cable, again, there's typically two subunits, electrical and fiber. So how you would terminate those currently would be really up to the user. There are suggestions. We use ferrules on our 16 gauge cable, and we plug it into a terminal block. That is currently the predominant method that we have. There's no standardized connector that includes both the fiber and the electrical.
Okay, so you'd use a normal fiber connector, LC or an SC, duplex, and then you'd use your ferrules. Gotcha.
Yes.
Gotcha.
Yep.
And I imagine at some point there'll be new technologies that will, there'll be some new connectors we might see out there that combine the two into one connector. So I'm sure things will change, just like they have, gosh, in the 37 years I've been doing this, things have changed quite a bit. So I'm sure we'll see new stuff coming out.
Yep. Class 4 is just getting started.
Yep. All right, great. Well, thank you everyone for joining us, and we will see you in a couple weeks with a special announcement.
All right. Thank you, Steve.